We left off talking about a situation in which a limit might not exist or does not exist. That's why we have the charismatic and somewhat troubled Lindsay Lohan here at the top of the screen, which I'm sure you're all familiar with. This was the example from class that we left off with. We had to say that this limit did not exist here because as we approached 0 from the left and from the right, we were getting different values. If you look at the values here as we approach from the left, it's never going to waver away from -1. Same thing here. It's going to be +1 as we approach from the right. Because these two numbers are not the same, we have to say that the limit does not exist. There is no definitive answer for what the function approaches as it approaches 0. Okay, so as you can see here, the three conditions for which the limit does not exist. The first one here is what we have on this previous slide. So the function, the y value of the graph, approaches different values from the left and from the right. So if you get a situation like this, the limit does not exist. Second situation in which the limit does not exist is if you have the function increasing or decreasing without bound. That's just a fancy way of saying that you have an asymptote at that value. So I've punched in a graph here that I can show you. So if you look at this function here, what you see are two asymptotes at -2 and at +2. So you can see these vertical asymptotes. So if I wanted to evaluate this limit, all right, so if you have this this screen right here, you're looking again, the asymptotes at -2 and at +2. So if I wanted to say evaluate the limit as x approaches, let's say -2 for that previous function, that one that I had graphed, we would have to say that that does not exist, because what are we going to say? What values of y is this function getting closer to? If you look at it from, I'm sorry, what did I say, 2? As x approaches -2, sorry. So if you look at the values as x approaches -2 from the left, it's shooting straight up. But as you approach -2 from the right, this is shooting straight down. And even if this asymptote was this part of the graph, even if it was going up to sort of mirror the left branch of this graph, we would still say that the limit does not exist. Because if it's approaching a value of infinity or -infinity, we say that the limit does not exist. The last example of how a limit does not exist is something rare that we don't see too much of, and that is the idea of this oscillating function. So if you have a graph of a function that is constantly going up and down like one of those, EKGs you see in the movies where the music escalates and somebody's obviously in some sort of physical peril, that's what you're seeing, is you're seeing this up and down motion over and over and over again. And what happens is it starts to happen very rapidly. So for example, if you look at this function, sine of x over x, if we tried to evaluate the limit as x approaches 0 here, even though you want to say, oh, it looks like it's 1, because this graph has this motion happening to it, it's oscillating back and forth, we cannot definitively say what that limit is. We don't see too many of these. I'm not concerned with this. I'm more concerned with the first two examples of when a limit may not exist. Let's go through a couple examples. We'll go through a couple examples in